This lesson is going to focus on inverse of matrix 3 by 3. So we're going to look at the inverse of 3 by 3 matrix. The inverse of a 3 by 3 matrix is given by, let's say, matrix A with its entries A, B, C, D, E, F, G, H, I. The inverse is adjoint of matrix A over the determinants of matrix A. But the adjoint of matrix A is equal to the matrix of cofactors. So inverse of matrix 3 by 3 will bring us to first of all determine cofactors. So I believe this is the first time you are hearing this term cofactors, especially if you have been following with the previous videos on metrics. We've never said anything about cofactors. So when we are trying to, or when we have to solve or look for the inverse of 3 by 3 matrix, we must come across cofactors, and we're going to look at that. So, but for us to be able to determine the cofactors of the matrix, we need to come back to what we came across when we looked at 3 by 3 matrix determinants, and that is the sign board. The matrix sign attached to B11, B12, B13, on and on from matrix B is given by the chessboard format. So given that this matrix B and these are the entries of matrix B, the sign attached to each of the entries is this, and we get this from the chessboard or from this function -1 raised to the power of I plus j, where I is row and j is column. So if you look at what we have with B11, to get the sign attached to B11, it means -1 raised to 1 plus 1, where the row, first to second column, you add them up together to get power 2. So -1 raised to power 2 is equal to +1. And B21 do the same thing, you get -1. So if you follow on and on until you get to B23, you get plus. So you put the signs, this is what you're going to get from using this function. So this matrix sign plus minus plus minus plus minus plus minus plus will play a prominent role in determining cofactor, and the concept of cofactors is needed in determining either the inverse of a 3 by 3 matrix or for determining the values of three unknowns simultaneously by using matrix. What this implies is that this concept of cofactors is useful in getting the inverse of it's useful when we want to get the inverse of a 3 by 3 matrix, most especially the adjoint of matrix E. That's where it's going to be very much useful. And then when we want to solve for three unknowns using simultaneous equation, or when we want to solve simultaneously for three unknowns using matrix, we are still going to fall back to adjoint of that matrix, and that will bring us to first of all getting the cofactors. And for us to get the cofactors, we must make use of this chessboard or the signs that attach to each entry. That is the procedure for determining the adjoint of a matrix. So we're going to take examples that will show clearly what this write-up means. So now we're going to look at the concept of cofactor for 3 by 3 matrix. The question says find the cofactors of the matrix A 1, 2, 3, 4, 5, 6, 7, 8, 9. So what we're going to do is remember our chessboard format is signs. Okay, so basically what we are expected to do is to reduce this 3 by 3 matrix to 2 by 2 matrix, where we're going to look for the determinants with the signs attached. So this is what we're going to do. The first thing, for us to get the entry, the cofactor form another matrix, but for us to do that, to get the first entry B11, we're going to B11 entry for the cofactor B11 cofactor entry. We're going to obliterate the first row and the first column. By obliterating, I mean we're going to cover or hide or just strike out the first row and the first column. So what we're going to have left is just this square matrix 5, 8, 6, 9, 2 by 2 matrix. And remember, for B11, the sign attached to it is plus. So it will be 5, 6, 8, 9. Then on and on for B2 to B12 rather actually minus. Then for B12, it will be the first row and the second column that you're going to obliterate. So the first row, second column, you're going to have 2, 3, 8, 9 left. 2, 3, 8, 9 left. B12, you're going to obliterate the first column. The sign is positive. First row, third column. So first row, third column. So you will have this left, this square matrix left 2, 3, 2, 3, 5, 6. So you do this on and on until you get to B23, entry for B23. So let's do it practically. I'm not going to strike it, I'm only going to use this is 1, 3, 7. I'm simply going to look at this without striking us, so it doesn't take time to get our square matrices. Okay, so the cofactors of the matrix A, I'll just write, okay, let me start. A is equals to, I'll write it as 1, 2, 3, 4, 5, 6, 7, 8, 9. So the cofactors will be the sign attached to the first entry is plus. So the first row, first column obliterated, I'm going to have this part yet. So 5, 6, 8, 9 minus, this side is minus, so first row, second column, 2, 3, 2, 3, 8, 9 plus, okay, the third row, first row, third column, 2, 3, and 5, 6, 2, 3, 5, 6 minus, we at second row, first column, that should be 3, 2, 1, second row, first column. So, and we obliterate the second row and the first column. So we're going to have 4, 6, 7, 9. 4, 6, 7, 9 plus the second row, second column, 1, 3, 1, 3, 7, 9 minus second row, third column, 1, 3, 4, 6, 1, 3, 4, 6 plus, now we have the third row, first column, 4, 5, 7, 8, 4, 5, 7, 8 minus third row, second column, 1, 2, 7, 8, 1, 2, 7, 8 plus third row, third column, 1, 2, 4, 5, 1, 2, 4, 5, 1, 2, 4, 5. So next thing we're going to do is to get our circle. So now we're going to get the values for these are determinants, so we're going to get values for each of these determinants, and each determinant here is an entry for the matrix, the entries that will form the matrix of the cofactors. So for this particular determinant, so the plus 5 times 9 is 45 minus 6 times 8, 48. Then minus 2 times 9 is 18 minus 8 times 2, 24. This is the second entry of the cofactors matrix plus 2 times 6, 12 minus 5 times 3, 15. Okay. Minus 4 times 9, 36. Minus 7 times 6, 42. Plus 1 times 9 is 9. Minus 7 times 3, 21. Minus 1 times 6, 6. 4 times 3, minus 12. Again, plus 4 times 8, 32. Minus 7 times 5, 35. Minus 1 times 8, 8. 7 times 2, 14. Plus 1 times 5, and minus 4 times 2, 8. So let's simplify. This is equals to 45 minus 48 is minus 3. Minus 3 times plus 1 is minus 3. 18 minus 24 will give us minus 6. Minus 6 plus times 18 minus 24 is minus 6. Minus 6 times minus 1 will give us plus 6. And 6. It's 12 minus 15 is minus 3. Minus 3. 36 minus 42. 36 minus 42 will give us 8. 36 minus 42 will give us 8. Minus 8. Minus 8 times minus 1 will give us 8. 9 minus 21 will give us 3. 9 minus 21 will give us 2. No. 21 minus 9. 11 minus 9 is 2. 1. 12 minus 12. So minus 5 times plus 1 will give us minus 12. Okay. 6 minus 12 will give us minus 6. Minus 6 times minus 1 will give us 6. 32 minus 35 will give us minus 3. Minus 3 times plus 1 will give us minus 3. Minus 3. Minus 3. 8 minus 14 is minus 6. Minus 6 times minus 1 is minus 6. 5 minus 8 is minus 3. Minus 3 times plus 1 is minus 3. So finally, this is the cofactors. This is the matrix of the cofactors. So this is basically how we get cofactors from given matrix, and this will be useful in determining the inverse of a matrix, and also when we need to solve for three unknowns using matrix simultaneously. So now we're going to look at the difference between cofactors and determinants. While we're looking at the concept of cofactors, we discovered that when we're looking for the determinants of 3 by 3 matrix, we make use of the chessboard format, that's the signs, and you could discover that there was kind of similarity, but there's a difference. So this subtopic will highlight the difference between cofactors and determinants, even though they seem to be resolved using the same pattern, but yes, it's noticeable difference. So let's start. This question says find A, the determinant, and B, the matrix formed by the cofactors of the matrix is given below. So let's start with number 1, D. Solution. Number 1, matrix D is equals to 1, 2, 0, 1, 2, 0, minus 3, minus 5, minus 1, 4, 7, 1. And so A says we should be for the determinant. Determinant of matrix D. Matrix D is 13 as follows. Matrix D equals so this will give us, so get matrix D, we factor out, we're going to use the first row, so we're going to factor out the first row alongside the lines assigned to each of the entries. So for the first row, the signs attached to each of the entries is plus, minus, plus. In determinant, we're going to make use of either the first row or second row or third row or the mix of the columns, but I decide to make use of the first row only. Factor out the first row, and then we derive our square matrices, and then we look for the determinant. So for the first one is plus 1, you arbitrate the first row and the first column. Minus 5, minus 1, 7, 1 will be left. Minus 3, and then arbitrate the first row and the second column. 2, 0, 7, 1 will be left. Then plus 4, arbitrate the first row and the third column. 2, 0, minus 5, minus 1, plus 1. Minus 5 times 1 is minus 5, minus 7 times minus 1 is minus 7. And minus times minus is plus 3. 2 times 1 is 2, minus 7 times 0 is 0, plus 4. 2 times minus 1 is minus 2, minus 5 times 0 is also 0. So plus 1, minus times minus 7 is plus 7, minus 5 plus 7 is 2, 2 times plus 1 is 2. And here, 2 minus 0 is 2, 2 times plus 3 is 6, plus 3. And here, minus 2 times minus 0 is minus 2, minus 2 times plus 4 is minus 8. So we're going to have 2 plus 3 is 5, 5 minus 8 is minus 2 plus 3, here's 6, plus 3 times 2 is 6. So here will be minus 5, 2 plus 6, 8, 8 minus 8 is 0. So our determinant is 0. So now let's get the cofactors of matrix D. Cofactors of matrix D. So now we get equals to, remember to get cofactors. So the difference between determinants and the matrix formed by cofactors is that for determinants, you attach the signs, but you factor out the row that you are using. If it's the first row that you are going to use, you factor out the entries alongside the sign. So here plus 1, you factor out the 1, and then you obliterate that the position of that entry, which is 1, 1, D11, which is the first row, first column. Obliterate the first row and the first column. You'll be left with a square matrix, and you get the determinant of that square matrix, which is what we did here to get our final answer, which is 0. But for cofactors, you're only factoring out the signs. You don't have anything to do with the values of the entries. So we proceed. So for this, first row, first column, the sign is plus. The factor is out, and then arbitrate the first row and the first column. You're going to be left with the square matrix: minus 5, minus 1, minus 5, minus 1, 7, 1, followed by minus. So minus first row, second column, 2 0 7 1 plus first row third column 2 0 0 4 2 0 4 1 2 0 third row first row third column 2 0 minus 5 minus 1 0 minus 5 minus 1 and followed by minus second row first column second row first column minus 0 minus 1 minus 0 minus 1 and 4 1 4 1 plus second row second column 1 0 1 0 1 0 second row second column 4 1 4 1 minus second row third column 1 0 minus 0 minus 1 1 0 minus 2 minus 1 plus third row first column minus 0 minus 5 minus 0 minus 5 4 7 minus third row second column 1 2 4 7 1 2 4 7 plus third row third column 1 2 1 2 minus 2 minus 5. Oh, next is we get so come back to this first entry, write our plus minus 5 times 1 is minus 5 minus 7 times minus 1 is minus 7 from here minus 2 times 1 is 2 minus 7 times 0 is 0 plus 2 times minus 1 is minus 2 minus 5 times 0 is 0 come to our third entry. 1 2 3 our third entry is minus 3 times 1 is minus 3 minus 4 times minus 1 minus 4 and here plus 1 times 1 is 1 minus 4 times 0 0 minus 1 times minus 1 is minus 1 minus 3 times minus 3 times 0 is 0 and here plus minus 3 times 7 is minus 21 minus 4 times minus 5 minus 20 minus 1 times 7 is 7 minus 4 times 2 is then plus 1 times minus 5 is minus 5 minus 3 times 2 minus 6. So when we evaluate those what we have inside this matrix, we're going to have the matrix of the cofactors D. So minus times minus is plus 7, minus 5 plus 7 is 2, 2 plus 2 times plus 1 is 2, and 2 minus 0 is 2, plus 2 minus 1 is minus 2, minus 2 minus 0 is minus 2, minus 2 times plus 1 is also minus 2. Minus times minus is plus, minus 3 plus 4 is 1, 1 times minus 1 is minus 1, plus 1 times 1 times 1 minus 0 is 1, 1 times plus 1 is 1, minus 1 minus 0 is minus 1, minus 1 times minus is 1, minus times minus is plus, minus 21 plus 20 is minus 1, minus 1 times plus 1 is minus 1, minus 1, 7 minus 8 is minus 1, minus 1 times minus 1 is 1, minus times minus is plus, minus 5 plus 6 is 1, 1 times plus 1 is 1, So this is the matrix formed. This is the matrix of the cofactors rather. So this is, you can see the difference between cofactors, matrix formed by cofactors, and the determinant. The determinants will have a value, but cofactors will have that 3 by 3 matrix. So these are the difference between the two. So that's for number 1. Number 2, matrix E minus 4, 1, 4, minus 6, 0, 2, minus 3, 1, 2. So E, to get determinants of the determinants of matrix E. Matrix E is so factor out. This is negative plus times minus 4. So first row, first column, 0, 2, 1, 3, and then minus 6. First row, second column, 1, 4, 1, 3. First row, third column, 1, 4, 0, 2. Plus times minus 4 gives us minus 4. 0 times 3 is 0, minus 1 times 2 is 2. Minus times minus 6 will give us plus minus 1 times minus 6 will give us plus 6. 1 times 3 is 2, minus 1 times 4, 4. Plus 1 times minus 3 will give us minus 3. 1 times 2 is 2, minus 0 times 4, 0. 0 minus 2 is minus 2. Minus 2 times minus 4 is 8. 3 minus 4 is minus 1. Minus 1 times plus 6 minus 6. 2 minus 0 is 2. 2 times minus 0 is minus 6. Okay, so this is 8 minus 6 minus 6. Minus 6 minus 6 is minus 12. 8 minus 12 is minus 4. So that's the determinant. B cofactors of matrix E. Cofactors of matrix E equals plus. So we obliterate the first row, the first column. We're going to have 0, 2, 1, 2, minus the first row and second column, 1, 4, 1, 3, 1, 4, 1, 3, plus first row, third column, 1, 4, 0, 2, 1, 4, 0, 2, minus second row, first column, second row, first column. So minus 6, 2, minus 6, 2, minus 3, 3, minus 3, 3, plus second row, second column, 1, 4, 1, 3, 1, 4, 1, 3, minus second row, third column, minus 4, 4, minus 4, 4, minus 6, 2, minus 6, 2, plus third row, first column, minus 6, 0, minus 6, 0, minus 3, 1, minus 3, 1, minus third row, second column, minus 4, 1, minus 4, 1, third row, second column, minus 4, 1, minus 3, 1, and plus third row, third column, minus 4, 1, minus 4, 1, and minus 6, 7, constant, plus 0 times 3 is 0 minus 1 times 2, 2 minus 1 times 3, 3 minus 1 times 4, 4 plus 1 times 2, 2 minus 0 times 4, 0 and minus 6 times 3 minus 18 minus 3 times 2 minus 6 plus 1 times 3 is 3 minus 1 times 4, 4 minus 1 times 2 minus 8 minus 6 times 4 minus 24 plus minus 6 times 1 minus 6 minus 3 times 0 0 minus 4 times 1 minus 4 minus 3 times 1 minus 3 plus minus 4 times 0 0 minus 6 times 1 minus 6. The matrix formed plus 0 times 0 minus 2 is minus 2. Minus 2 times plus 1 is minus 2. 3 minus 4 is minus 1. Minus 1 times minus will give us 1. 2 minus 0 is 2. 2 times plus 1 is 2. 2 minus 18 minus 6. Minus 18 minus 6 will give us minus 24. Minus 24 times minus 1 is 24. 3 minus 4 is minus 1. Minus 1 times plus 1 is minus 1. Minus times minus is plus. Minus 8 plus 24 will give us 16. Minus 8 plus 24, yes, will give us 16. 16 times minus is minus 16. Minus 6 minus 0 is minus 6. Minus 6 times plus 1 is minus 6. Minus times minus is plus 3. Plus 3 minus 4, or minus 4 plus 3 is minus 1. Minus 1 times minus 1 is 1. And minus times minus is 6. Plus 6 plus 6 times plus 1 is 6. This is the matrix of the cofactors. I need to correction here. It's not 24. This part here. Minus 3 times 2 is minus 6. Yes, minus 6. So minus times minus is plus. So minus 18 plus 6 will give us 12. Minus 18 plus 6 minus 12. Minus 12 times minus 1 is 12. Oh, that's the answer. Number 3. Answer is F. 1 minus 2, 7, minus 1, 3, minus 3, 0, minus 4, 5. So E, the determinant of matrix F is matrix F plus 1, 3, minus 3, minus 4, 5, minus 1, minus 2, 7, minus 4, 5, and plus 0, 1, minus 2, 7, 2, minus 3, plus 1, 3 times 5, 15, minus 2 times minus 3 is plus 12, plus 12, minus times minus is plus 1, minus 2 times 5, minus 10, minus 4 times 7, minus 28, plus 0. Minus 2 times minus 3 is 6. 3 times 7 minus 21. 15 minus 12 is 3. 3 times plus 1 is 3. Minus x minus is 12. Minus x minus is plus. Minus 10 plus 28 is 18. Yeah. Minus 10 plus 28 is 18. Plus 18. 6 minus 21 is minus 17. No, 6 times 21 is 13. 6 times 21 minus 6. 0 minus 6, 11, 6. 11 minus 6 is 5. Minus 15. Minus 15 times 0 is plus 0. 3 plus 18 is equal to 21. So that's the determinant of matrix F. Cofactors of matrix F equals to plus first row first column 3 minus 3 minus 4 5 minus first row second column minus 2 7 minus 2 7 minus 4 5 plus first row third column minus 2 7 3 minus 3 minus second row first column minus 1 minus 3 minus 1 minus 3 0 5 plus second row second column minus 2 1 7 second row first column, yeah, minus 1 minus 2 0 5 second row second column 1 7 1 7 0 5 0 5 plus minus second row third column 1 7 minus 1 minus 3 plus third row first column minus 1 3 minus 1 3 0 minus 4 minus third row second column 1 minus 2 first row third column second column 0 minus 4 0 minus 4 plus third row third column 1 minus 2 1 minus 2 minus 1 3 minus 1 3. So plus 3 times 5 15 minus 4 times minus 0 is plus 12 minus 2 times 5 is minus 10 minus 4 times 7 minus 28 plus minus 2 times minus 3 is 6 2 times 7 21 yes minus 1 times 5 minus 5 minus 0 times minus 2 0 plus 1 times 5 is 5 minus 0 times 7 0 plus minus 1 times minus 3 minus 3 minus times minus 1 times 7 minus 7 plus minus 1 times minus 4 is 4 minus 0 times 3 is 0 minus 1 times minus 4 minus 4 0 times minus 2 0 plus 1 times 3 is 6, minus 1 times minus 2 is 2, equals to 15 minus 12 is 3, minus times minus is 12, plus minus 10 plus 28 is 18, 18 times minus 1, minus 18. 6 minus 21 is 15, minus 15 times 3 times plus is minus 15. Minus 5 times minus 0 is minus 5, minus 5 times minus 1 is 5. 5 minus 0 is 5, 5 times plus 1 is 5. Minus x minus is plus, minus 3 plus 7 is 4, 4 times minus 1, minus 4. 4 minus 0 is 4, 4 times plus 1 is 4. Minus 4 times minus 0 is minus 4, minus 4 times minus is 4. 6 minus 2 is 4, 4 times plus 1 is 4. So, correct. Look at 1 times 3 is 3. 1 times 3 is 3. Minus 1 times minus 2 is 2, which is what we have here. So 3 minus 2 is 1. 1 times 3 is 1. This is matrices of the cofactors of F. Now let's look at the inverse of matrix 3 by 3 properly. Since we're going to need the knowledge of cofactor, I decided to start off with how to get the matrix formed by cofactors, and from there I also had to differentiate cofactors from determinants because they share similarity. Now we're going to look at how to get the inverse of a 3 by 3 matrix from the knowledge we have gotten from cofactors and determinants. So look at the steps. For step 1, where basically E is telling us to look for inverse A raised to minus 1, which is the inverse of matrix A. And to do that, A inverse is equal to adjoint A over determinants of A. So step 1 says find the determinants of matrix A. Step 2, find the cofactor of matrix A. Step 3, transpose the cofactor of matrix A to get adjoint A. So adjoint A is the transposition of the matrix formed by the cofactors of matrix A. And then we evaluate, which is step 4. So let's proceed. Solution. Yeah. So we're going to step 1. Step 1. Find the determinant. The determinant is the first one. From our matrix then, we're going to have plus 1. First to the first column, 1, 2, 3, 1. Minus 0. First to the second column, 2, 4, 2, 4, 3, 1. Plus 1. First to the third column, 2, 4, 1, 2, 2, 4, 1, 2. 1 plus 1 times 1, 1, 3 times 2, 6, minus 0, 2 times 1, 2, minus 3 times 4, 12, plus 1, plus 1, 2 times 2, 4, 1 times 4, 4. 1 minus 6 is minus 5, minus 5 times plus 1, minus 5. 2 minus 12 is minus 10, minus 10 times 0 is minus 0. 4 minus 5 is 0, 0 times plus 1 is 0, plus 0. So minus 0 plus 0 is 0, so our determinant is minus 5. Step 2, Find cofactor of E. So it's a cofactors of E. Cofactors of E are plus first row, first column, 1, 2, 1, 2, 1, 2, 3, 1 minus first row, second column, 2, 4, 3, 1, 2, 4, 3, 1 plus first row, third column, 2, 4, 1, 2, 2, 4, 1, 2 minus second row, first column, 0, 2, 1, 1, 0, 2, 1, 1 plus second row, second column, 1, 4, 1, 1, 1, 4, 1, 1 minus second row, third column, 1, 4, 0, 2, 1, 4, 0, 2 plus third row, first column, 0, 1, 1, 3, 0, 1, 1, 3 minus third row, second column, 1, 2, 1, 3, 1, 2, 1, 2 plus third row, third column, 1, 2, 0, 1, 1, 2, 0, 1. So plus 1 times 1, 1 minus 3 times 2, 6 minus 2 times 1, 2 minus 3 times 4, 12 plus 2 times 2, 4, 4 minus 1 times 4, 4. Yeah. Okay, so minus 0 times 1, 0 minus 1 times 2, 2 plus 1 times 1 is 1 minus 1 times 4, 4 minus 1 times 2, 2, 0 times 4 is 7 plus 0 times 3 is 0 minus 1 times 1 is 1 minus 1 times 3 is 3 minus 1 times 2 is 2 plus 1 times 1 is 1 minus 0 times 2 is 0. So 1 minus 6 is minus 5. Minus 5 times plus 1 minus 5. 2 minus 12 is minus 10. Minus 10 times minus 1 is 10. 4 minus 4 is 0. 0 times plus 1 is 0. 0. 0 minus 2 is minus 2. Minus 2 times minus 1 is 2. 1 minus 4 is minus 3. Minus 3 times plus 1 is minus 3. 2 minus 0 is 2. 2 times minus 1 minus 2. 0 times minus 0 minus 1 is minus 1. Minus 1 times plus 1 is minus 1. 3 minus 2 is 1. 1 times minus 1 minus 1. 1 minus 0 is 1. 1 times plus 1 is 1. So to get our adjoint step 4 is step 2, step 3. Let's get our adjoint of matrix A, which is equals to the transpose. What's the transpose? That means, okay, I say that is transpose matrix formed by cofactors. find the cofactors of E. So adjoint of matrix E was minus 5, 10, 0, 2, minus 3, minus 2, minus 1, minus 1. That's our adjoint. Step 4, to evaluate E inverse adjoint of E over determinant. E inverse is equals to 1 over determinant over adjoint minus adjoint of E matrix E. This is our determinant is minus 5, so minus 1 over 5 minus 1 over 5. And so adjoint of matrix A, which is the transpose matrix formed by cofactors of E, is minus 5, 10, 0, 2, minus 3, minus 2, minus 1, minus 1, and 1. So this is the inverse of matrix E, and this is the answer to E part. B part says show that A multiplied by E inverse is equals to identity matrix where I is an identity matrix. So because we're going to multiply, we're not going to leave our answer like this. We're eventually going to multiply matrix, this inverse matrix by A, and this A, the matrix of A will come first. So here we left it in this form. So let's simplify this part. So our joint E inverse is equals to minus 1 over 5 divided times minus 5, that's plus 5 over 5, which is equals to 1. And then minus 1 over 5 times 2 will give us minus 2 over 5. Gives us minus 0.4. Minus 1 times minus 1 is equals to 1 over 5. 0.2. 0.2. And here minus 1 times 10 gives us minus 10 over 5, that's minus 2. Minus 1 times minus 3 over 5. Minus 1 over 5 times minus 2 gives us 3 over 5. 0.6. And minus 1 times minus 1 over 5 is 1 over 5. And that is 0.2. 0 minus 1 over 5 times 0 will give us 0. Minus 1 over 5 times minus 2 will give us 2 over 5. 0.4. Minus 1 over 5 times 1 is minus 1 over 5. And that is minus 0.2. So this is correct for E inverse. So now we're going to look at show that E inverse so show is equals to where our matrix E is equals to matrix E is equals to 1, 2, 4, 0, 1, 2, 1, 3, 1, and A inverse was 1 minus 0.4, 0.2, 0.2 minus 2, 0.6, 0.2, 0, 0.4, and 0.2. This is equals to 1 times 1 is 1 times 1 plus 0 times minus 2, 0 times minus 2 plus 1 times 0, 1 times 0, 1 times 0. Okay, 1 times minus 0, 1 times, 1 times minus 0.4, 1 times minus 0.4 plus 0 times 0.6 plus 1 times 0.4, 1 times 0.4, and come to here 1 times 0.2 plus 0 times 0.2 plus 1 times minus 0.2, 2 times 1 plus 1 times minus 2 plus 3 times 0, 2 times minus 0.4 plus 1 times 0.6 plus 3 times 0.4, 2 times 0.2 plus 1 times 0.2 plus 3 times minus 0.2, 4 times 1, 4 times 1 plus 2 times minus 2 plus 2 plus 2 times minus 2 plus 1 times 0 and 4 times minus 0.4 plus 4 times minus 0.4 plus 2 times 0.6 plus 1 times 0.4, 4 times 0.2 plus 2 times 0.2 plus 1 times minus 0.2. Awesome. So 1 times 1, so 1 times 1 is 1 plus 0 times minus 2 is 0 plus 1 times 0 is 0. So 1 plus 0, 1 plus 0 is 1. 1 times minus 0.4 is minus 0.4 plus 0 times 0.6 is 0 plus 1 times 0.4, 0.4. So 0.4 minus 0.4 plus 0.4 is 0. And is 1 times 0.2 is 0.2, 0.2. 0 times 0.2 is 0 plus 0. And 1 times minus 0.2 minus 0.2. So 0.2 minus 0.2 is 0. 2 times 1 is 2. Is 2. 2 times 1 is 2. 1 times minus 2 is minus 2. 3 times 0 plus 0. 2 minus 2 is 0. 2 times minus 0.4 is equals to minus 0.8. 1 times 0.6 plus 0.6 plus 3 times 0.4 is equals to 1.0.8. 0.4 times 3, 1.2, 1.2, and 2 times minus 0.4. So 1.2 plus 0.6 equals to minus 0.8 plus 1.8. So minus 0.8 plus 1.8 will give us 1. So here's 1. 1. 2. 2 times 0.2 is 0.4. 1 times 0.2 plus 0.2. 3 times minus 0.2, 0.6 minus 0.6. So plus 0.2 minus 0.6 will give us 0.4 minus 0.4, which will give us 0. So 4 times 1, 4 times 1, 4 times 1 is 4. 2 times minus 2, minus 4. 1 times 0 is plus 0. 4 minus 4 is 0. 0 plus 0 is 0. 4 times minus 0.4 is 1 point minus 1.6 minus 1.6. 2 times 0.6 is plus 1.2, and 1 times 0.4 plus 0.4. So minus 1.6 minus 1.6 plus 1.2 plus 0.4 is 1.6. Minus 1.6 plus 1.6 is 0. 0. 4 times 0.2 is 0.8. 0.8. 2 times 0.2 is plus 0.4 plus 1 times minus 0.2 minus 0.4 minus 0.4. 1 times 0.4 minus 0.2. 1 times minus 0.2 is just minus 0.2. So plus 0.8 plus 0.4 will give us 1.2. 1.2 minus 0.2 equals to 1. That's 1. So what we have is identity matrix, where if you go diagonally, you have 1, 1, 1, and then the other entries are equal to 0. So this is identity matrix. Therefore, since the question said we should prove or show that A multiplied by A inverse equals to I, which is identity matrix. Therefore, A multiplied by A inverse equals to I, where I is identity matrix, where I is an identity matrix. Right. Solution. Matrix C. Inverse of matrix C is C inverse equals to adjoint of matrix C over adjoint of matrix C over determinant of matrix C. So first, let's find matrix C, or determine determinant of matrix C. So determinant of matrix C is equals to plus 1. Let's do first column 1, 5, 1, 5, 2, minus 1, minus 2, First row, second column, 3 minus 4, 3 minus 4, 2 minus 1, plus minus 3. First row, third column, 3 minus 4, 1, 5. And determinant equals to plus 1. 1 times minus 1 is minus 1. Minus 2 times 5 is 10. Minus 2. 3 times minus 1 is minus 3. Minus 2 times minus 4. Minus 8. Plus times minus 2 is minus 3. 3 times 5 is 15. 3 minus 1 times minus 4. Minus 4. Plus 1. Minus 1 minus 1 is minus 11. Minus 2. Minus times minus is plus. Minus 3 plus 8 is 5. Minus 3. Minus times minus is plus. 15 plus 4 is 19. Minus 11 times plus 1 is minus 11. Minus 2. Minus 10. Minus 3 times 19 is minus 57. This will give us minus 57, 11, 10, 1, 2, 21, 5, 7, 8, 7. So this is minus 78. So our determinant is minus 78. And next, and the matrix formed by the cofactors of matrix C. That is it. So this will give us, so for first row, first column, 1, 5, 1, 5, 2, minus 1, minus first row, second column, 3, minus 4, 3, minus 4, 2, minus 1, first row, third column, 3, minus 4, 3, minus 4, 1, 5. Minus first row, second row, first column, 2, 5. 2, 5, minus 3, minus 1, plus second row, second column, 1, minus 4, 1, minus 4, minus 3, minus 1, minus second row, third column, 1, 2, minus 4, 5, 1, minus 4, 2, 5, plus third row, first column, 2, 1, 2, 1, minus 3, 2, minus third row, second column, 1, 3, 1, 3, minus 3, 2, plus third row, third column, 1, 3, 2, 1. person plus 1 times minus 1 minus 1 minus 2 times 5 10 minus 3 times minus 1 minus 3 minus 2 times minus 4 minus 8 plus 3 times 5 15 3 minus 1 times minus 4 minus 4 minus 2 times minus 1 minus 2 minus 3 times 5 minus 15 plus 1 times minus 1 minus 1 minus 3 times minus 4 12 minus 1 times 5 5 minus 2 times minus 4 minus 8 plus 2 times 2 4 minus 2 times 1 minus 3 minus 1 times 2 2 minus 3 times 3 minus 9 plus 1 times 1 is 1 minus 2 times 3 6 minus 1 times minus 10 minus 11 minus 11 times 11 plus minus 1 minus 11 times plus 1 equals minus 11 minus times minus is 8 minus 3 plus 8 is 5 5 times minus 1 is minus 5 minus times minus is plus between plus 4 is 19 times plus 1 is 19 and minus times minus is plus minus 2 plus 15 is minus 30 is plus 13 minus times minus is plus minus 2 plus 15 is 13 10 times minus 1 is minus 13 minus times plus 12 minus times 12 is minus 12 minus 12 minus 1 is minus 13 minus 13 times plus 1 is minus 13 plus minus times minus is plus 5 plus 8 is 13 13 times minus 1 is minus 13 minus times minus is plus 4 plus 2 is 7 7 times plus 1 7 minus times minus is 9 2 times 2 plus 9 11 11 times minus 1 minus 11 1 minus 6 is minus 5 minus 5 times plus 1 is minus 5 so we've gotten the matrix formed by the cofactors of C. So remember, to get C inverse, we need to get the adjoint of C. And the adjoint of C is especially to transpose the matrix formed by the cofactors of the matrix of C. So next transpose matrix of the cofactors. Transpose matrix of the cofactors of C. So this will give us adjoint C. Adjoint equals to C equals to when transpose minus 11 minus 5 19 minus 13 minus 13 minus 13 7 minus 11 minus 5. Then once you have done that, the next thing is to evaluate. Then evaluate. I think this will be the next section. Then evaluate C inverse equals to adjoint of C over C determinant. So C inverse is equals to 1 over determinant C multiplied by adjoint of set matrix C, which is equals to minus 78 minus 1 over 78 bracket open. Measures as minus 11 minus 13 7 minus 5 19 minus 13 minus 13 minus 11 minus 5 minus 11 minus 5. So that's the final answer.